Yeah, we've not done a stream in ages, maybe since before November, I think. So like at least 3 months without one. Oh God, there's quite a lot of people. Cool. I've got the screen, I've got my scaling set up to like 150% as well, and I've got the UI scaling turned up as well in Blender, so hopefully you should be able to see everything I do. I've got a really big monitor, like 30 inches, so when my scaling's this big, everything's like an inch across. It makes me feel like a 6-year-old. It's pretty fun. Okay, sweet. I'm just gonna jump in. So to begin with, I just want to say thank you to everybody who's on this server, because we've just passed 1,500 members, which is crazy. Like, we started this Discord server, me and Sharon, because we wanted somewhere that was easy for us to do streams and like share ideas about things. So it's just really cool that other people have kind of jumped in and made it a proper community. So thank you. And we're giving away Hard Ups Box Cutter. So I've just got another key from Master Xeon. So he just said that we could give away another key for that. So how many people are in here? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh wait, that's including me, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. New Taki. There we go. It's difficult with popular add-ons like that because, yeah, like a lot of people have it. But it's a super useful one, so congrats, New Taki. I will send you the link afterwards. Just remind me if I forget. Yeah, congrats, man. You're going to stick with Grid Modeler. Grid Modeler is great, actually. I see so many people using it. It looks really cool. And he keeps adding features like really quickly as well. So he's doing a great job. Okay, so yeah, his time lapses are really cool. So for geometry nodes, for anybody who doesn't know, and also any links that I share on the Discord chat, I will share in the YouTube description. So if you want to be using geometry nodes at the moment, you're going to need either 2.92 beta or 2.93 alpha. And for this session today, we'll be using 2.93 because it has a few more nodes that have just been added since 2.92 got frozen. So yeah, obviously if you're watching this in the future, you may find that we're using nodes that look different or that no longer exist. So you'll just maybe have to feel that out a little bit. So if you want to grab an alpha or beta build, you just need to go to the builder.blender.org. Eric asks what the future is like as well, so be sure to drop that down in the comments. If you want to know more about the project, the Geometry Nodes project, there is this blog, the developers blog, and you can read a few of the entries about sort of where they were planning on taking it and the sort of the scope of the project, and yeah, things where they thought it was going to come in useful in other projects, right? Past projects they've done. The dev talk is super useful. This is like a really valuable list of, well, it's just like a conversation, right? So the developers are in here and people who are using geometry nodes are in here, and there's like a bit of back and forth. So it's really useful if you run into issues. I've posted in here and then people have come back, and it's just been super useful to have that kind of back and forth. So let me just drop some links in the chat. So that's for the blog and that's for the dev talk. So both super useful. And then also we have some documentation. So I know, yeah, obviously a lot of the things that we're going to be using with geometry nodes are kind of new workflows for a lot of people. So attributes, a lot of people won't have used. Yeah, I think attributes is probably the main thing. And also we now have multi-input sockets, so that's kind of a new thing as well. So that's documentation. And this will cover things like built-in attributes in here. So there are some which already exist. This isn't all of them, because there's things like normal, I believe. Oh, I mean, I've used normal as an attribute and that returned a vector. So yeah, Houdini vibes, yeah. There's a few more things in here. So density, ID, radius, rotation, scale, and temperature. This is just another resource, which is quite useful. And that's all of the ones that I've picked up for today. You can also check the development, like the actual development and the commits that people are making, and you can subscribe to that. So like every day I get, I don't know, 20 or 30 emails just saying like, oh, this person has done a new commit, or this new proposed node has been added. So that's also very useful. Yeah, temperature. I think temperature is used for volumetrics, I think, because you sometimes see it on the volume, like the principled volume node. But just jump into here, shader, principled volume. Yeah, they've got temperature attribute and a density attribute. I guess this is probably if you're doing shaders with like MantaFlow or like fluids and stuff. How fast it rises. Oh yeah, that would make sense. Yeah, if you're doing gas simulations. Okay, so we're just going to have a little bit of a play around with geometry nodes to begin with. I don't want to just show you the kind of the route to the final answer, just because it's more about the workflow. So to begin with, we're just going to add a plane and then add a new geometry nodes node tree to it. So there's two ways of doing this. You can either, if you change one of your node editors over to the geometry node editor, with your object selected, we can click new at the top of here as if we were adding a new material, but it's going to add a new geometry node setup, and it's specific to the object. So on your modifier stack, you'll be able to see that we've got a new modifier has been added called geometry nodes, which you can find here. And it's selected the correct node tree by default. So naming things is super important. So I'm just going to rename this one to displacement. And we're going to have a look at doing a simple displacement as if we were using a displacement modifier, but doing it with geometry nodes actually does give you a few more options, because you can start playing with attributes. And if you're using cycles as your render engine, you can pull an attribute into the shader to control stuff there, which is quite cool. So I'll just walk you through that process. So displacement, normally we would use a subdivision modifier and then a displacement modifier, but we can do everything inside geometry nodes here. So I've got my nodes. First of all, I need to subdivide the mesh, so Shift A, and then we want to add a mesh subdivision surface. So this is just essentially a node version of that of the modifier. Now in the future, I saw a few things that said that maybe the simple subdivision model is going to be a separate node to the Catmull-Clark one. I'm not sure if that's actually going to become a thing, but as far as I'm aware, they're going to be separated out because of a different like smoothing algorithm or something. But you can see if I'm in wireframe view here, the levels is literally just subdividing that plane. Every operator a node. It would be cool, or even just like a script node, right? That you could call an operator on and use Python directly in the nodes. I don't know how it'd work in terms of like your data flow. You'd have to be, and like the dependency graph. And then obviously you've got stuff like sharing attributes between objects. Then it becomes a bit more difficult because you've got things like your built-in attributes like scale and rotation. They're very specific to your object, and you don't necessarily want to be calling them across multiple objects. Right, so we have a subdivided, essentially a subdivide simple mesh on our plane. And now we need to think about how we're going to move the plane up and down. So with the displacement modifier, you would use a texture, and you have to use the texture properties for geometry nodes as well. So we don't have any like noise nodes or Voronoi nodes. Everything has to be done with the texture properties. So I just have some default ones that I have in my start file, but I'm going to create a new texture, change it to clouds, which is noise. And I'm just going to leave it as defaults for now. So what we want to do is we want to call this texture into geometry nodes, and we do this with an attribute sample texture node. Let's throw this on here. And this has a few options. So this is when we're going to start using attributes. So let's call our texture, let me just rename it as well to clouds. So mapping. Mapping is basically like UV map, or I think you might be able to use generated. Do you know what, we'll try in a sec once we've got the rest of the displacements sorted, but I'm just going to set mine to UV map. And that's with capital UVM and then lowercase ap. And that is just because that is the default UV map name. So this mapping, if you're using UV mapping, needs to match the UV map name in here, right? So it's important that these are exactly the same, so it knows what it's calling, like what attribute it's calling. Equally, if you're using vertex groups, it's important that the name is the same, like case sensitive as well, between vertex group and the attribute that you're calling. So we've got our clouds and we're mapping it to the UV map. And then we need to have a result, right? So at the moment it doesn't really know what to do with this information. So I'm just going to call this one height. So I've created a new attribute because it's not one of the predefined ones, right? It's not scale or rotation or position. If you give it a new string, right, a new line of letters or numbers, it's going to create a new attribute called that. And you can think of this as a spreadsheet. So you have your mesh and you've got your vertex positions, and then you have like a list of edges and faces, and then you've also got a list of attributes. Now, will the attribute be saved even if not in use? I think if you generate it, now I'm not 100% sure on this, but I think if you generate it, then it creates it. And if I was to delete that, then I would think that it would remove the height attribute. It might be something like orphan data where it has to restart Blender or do a cleanup or something. But I would think that it just removes that column essentially from the spreadsheet. So at the moment I'm not using height for anything, but I have still created it. So in this case it is there. And the same with any nodes in Blender, we're working from left to right. So anything that you create on the left, you can then use subsequently as you go across. So we have our texture. Now I need to make it displace the surface. And for this, we're going to use a attribute mix node. Just trying to think here. An attribute mix node. And also at the moment we have scalar values. So that's another thing to consider. How do we turn scalar values into z-axis values? Because we're only just working on a plane at the moment, so we only want to displace things vertically upwards. So if we have a value, we need to do something to it to turn it into just the z component of a vector. And we can do this with a combine xyz. So an attribute combine xyz. So you can see in here, we have some options. And a lot of the nodes in geometry nodes are like this. You'll have the option between using a float or a vector or a color or an attribute for each one of the inputs. So you're essentially kind of creating things yourself. So what I want to do is I want to have height be my z component and then 0, 0 for my x and y. So I'm going to change my type z to attribute, change this to height. And instead of typing it, you can just hover over a previous one, Control C, Control V. And then I'm going to call this one height again, right? So it's got the same name. We've overwritten the previous attribute with this new one, which is now a proper vector that we want. Let me see if I've got screencast keys on here. Shortcut viewer, I'll do. Okay, so if you need any of my shortcuts, they are on the left hand side. So you should have the combine node if you're using 2.93 from the last few days, like the last, I think 4 days, 3 or 4 days. If you don't have combine XYZ, then don't worry, you can always just use an attribute vector map, and then you multiply your height by the vector 0, 0, 1, and then output height. Right, like that. So if you don't have the combine, then you can just essentially multiply it by this 0, 0, 1 vector, and this will create the same thing. It's just kind of neater to do it with the combine XYZ if you have access to that. Okay, so now we've got our height as a vector, and we need to move the points of this plane. So what we're going to do is we're going to add the vector that we've got to each of the positions of the plane. Okay, so the positions are essentially the vertices as they are currently. So we can type in position. This is a predefined vector. We're going to add height, and our output is going to be position, because it needs to know that we're using the, or that we're overwriting the position, right? So POS, TION. And now you can see that we've displaced that mesh. So this factor is going to move that up and down. And if you wanted to change the mid-level, you could always subtract 0.5 from your height. So you could use an attribute math node, do a float here, subtract, and then I'm just going to put height into both of these. So now you can see that we have this difference in height here, 0.5. So there you go, you can see that we can now displace a mesh entirely inside geometry nodes, which is really cool, because with everything being non-linear, and when I say non-linear, I know these node trees look super linear because they just take the geometry each time and we're always going in this direction. But if you had something like an input value node, right, then you can always plug something like this in to multiple positions. So you can start having much more kind of interconnectedness between different parts of your node tree. So what happens if you want to take an attribute into the shader to control something? Well, let's do this here. So I'm going to create a new attribute for, here we go, for the factor. So the factor is the amount of the displacement that we're putting onto this this plane. So I need this to be a factor, to be a vector. No, an attribute. It needs to be an attribute. So change your factor to an attribute, and I'm just going to call this one blend because we're blending between. And I also need to define what my blend value is. So let's take an attribute fill. And I think, so when I was doing this a couple of days ago, I had a bit of a glitch with using float value attributes and bringing those into my shader graph. I was having to use a color instead, which I think is probably still fine in this case because it's just going to be passed as a scalar value in our mix. So we're going to use attribute fill to define what blend is. And at the moment it's 0, right? So you can see if I move this color up and down. Oh, you're not sure what a float value means? Okay, so a float, I don't know why it's called a float value, to be honest. It should be called a scalar value. But basically a float is not an integer. So like 0.2 or 1.6, these are float values. Whereas a scalar is not a vector. So I think that's really what it's trying to get at, is that it's essentially in shader nodes, it would be a gray socket, as opposed to a vector, which has 3 components, or a color vector, which is like RGBA, so a vector 4. So in this case, I want to have a slider or just a value input here. So I'm just going to plug a value into my color. And here we go. So now I've got this working like this. You could set this to float if you want and just see if it works for you. I was having glitching. But now if I make a shader, so let's change over to a shader editor, create a new material. And then I'm going to throw in a mix RGB. Let's just view this and let's flip between red and blue. So our mix is going to flip here and we need an input attribute node. I'm just going to take the color into my factor here, rename this one to blend, which is the attribute that we declared. So at the moment, this doesn't seem to be doing anything, to the color at least. But this is just because we're using EV. So material preview mode is EV. We need cycles if we're going to be using the attributes. So you can see that as we go to a flat surface, let me just go through a diffuse as well. So as we go through a flat surface to the displaced surface, we are flipping in between the red and the blue. So you can start having this real like interconnectedness by using attributes and calling attributes between your shaders and your geometry nodes. But this only works within a single object. Yeah, so hopefully this makes sense. I know I've spent a little bit of time on this, but the rest of this we will go a little bit, maybe a little bit brisker. Let me know if you have any questions or if you aren't keeping up or anything, because I can always slow down again. So, for the music equaliser effect, what we want to do is have basically from mix to add on the attribute mix. Yeah, it does make a big difference because we're taking the original positions and moving them up and down. It's important that you use, go to object mode, add, because mix is going to go to the middle, right? Because it's just a vertical vector. You're only creating vectors between essentially 0 and 1 on the Z, but nowhere on X and Y. So that's why it compresses to the middle. And you know how much I love mixed nodes, but we have all of these things. We've got linear light on here, so you can have as much fun as you can have with a mix RGB as well. Okay, so we do not need to have the attribute mix or fill nodes. If you ever just want to pull something off a noodle, you press Alt and drag it. So just Alt and drag and it won't break the noodle. Oh, actually, I did need the mix because I need to displace vertically. And I'm just going to use a float for the vector here, for the factor. Okay, so for the music thing, we want to have lines, right, that sort of wiggle past each other. And then when there is a sort of an impulse in the music, when there is a louder beat, it's going to distort these lines, right? So it just looks like a graphic equalizer. Yeah, linear light. Do you know what? I'm not actually sure why I use linear light in this setup. No, I'm sorry, we don't. We only use multiply, add, and divide. What a letdown. I should have worked it in somewhere, but I guess I couldn't. I'm sorry. Okay, so if we want to have lines, then you don't always have to put faces into geometry nodes. You can just use edges, right? It's going to read vectors as in like the points, and the edges just on their own. That's going to be fine. So rather than using a plane where we're getting all of this like two-dimensional noise displacement across the full thing, I'm just going to break this down into edges. So let me hide the geometry node setup. So I'm just going to disable that modifier. So we can do that just like normal. I'm going to create a bunch of loop cuts with Control R. And then I'm going to select my two end rows here and here. Let's go to wireframe so you can see that. So I've just selected the two end ones and I'm going to go X and delete edges. So now we have got these horizontal ones. Yeah, although they're in the wrong orientation. There we go. So I just wanted them to be in the X direction, just so that it's just a bit easier on the maths. I can just think about keeping things in X. And another thing I'm going to do is I'm going to scale them down so they're a little bit closer together in the Y axis, right? So there, you just have like this rack. Cool, so now if I go back and turn on my geometry nodes, nothing's happened. But this is because, so this is because we no longer have a face, so we no longer have a UV map. I think that's right anyway. So instead of using the UV map, in this case, we're going to use something else. We're going to use position. So we're just taking the location, essentially, of each of the vertices, and then that's calculating what its displacement should be. So when we do that, you can see that we're displacing the surface again, or specifically the points. I'm going to increase the size of my noise, something a bit more like this. And there we go. So it's already looking pretty cool, but they're all displacing like the same. This might be what you're going for, but I would like each edge to have like a way different displacement, so it looks like it's out of phase from each other, or just that it's got a different noise on it. So what we need to do is we actually need to modify the mapping coordinates. So because we're using a pre-made vector here, the position, and we're going to call that later, I'm going to make a new attribute that is some function of the position. So hopefully this makes sense. So I'm going to put this in before the sample texture because we need to use it with the sample texture. So I'm going to just call this new attribute mapping. Just something easy for us to consider. And then, so it's just gone down because I have my mid-level on this attribute set. If I set it to 0, then that's just on the 0 position. So we need to take the position, and I'm going to scale it in the y-axis. So at the moment, each one of these is like, I don't know, 5 centimeters apart or something. And so when we put the noise through it, each cut through that noise is very close together. So what I'm going to do is I'm going to scale up the position vector in the y direction, and that's going to compress that noise so that each line gets a more different position, essentially. So what we're going to want to do is take an attribute and an attribute vector math. So this is something that's caught us out before, is using attribute math instead of vector math, because you don't always think in your head, oh, I'm using vector math or I'm using math when you're talking about attributes. But just be aware, like if you've got a rotation and you want to scale it, then rather than multiplying it by a float with the attribute math node, what you need is to use a vector math node and to scale it in here so that you're maintaining that vector that vector workflow. That's just something that you just need to be aware of. If something's rotating weird or it's positioned weirdly, you don't quite know why, especially if it's on the the x equals y equals z line that basically goes up at 45 degrees from like this, right? So every time you see something going off in that direction, it's basically because you've compressed it down to a scalar value. So what I'm going to do here is I'm going to take my position and we're going to multiply it by a vector. Had a call, could somebody maybe share a blend file of the current state of course? Cool. There you go, that's my one. Right, so yeah, we're taking the position, we're creating a new attribute called mapping. Sorry, I jump around a bit while I'm thinking about this stuff. And then we need to multiply it by, so 1 would just be the position, right? So that's giving us this. And then we need to increase the scale of the y-axis so that each one of these lines has a significantly different mapping position. So that's already looking a lot better. So I'm going to set mine up to like 5. I think that's enough. So right now we have this, and like another thing that I want to do is I want everything to move along horizontally. So I want everything to essentially add a value in the x direction. So literally the same thing again here. So take an attribute math node. I'm going to put it after this one because we've already declared mapping. So I'm taking mapping and I'm going to add a vector to it. So let's just set this all to 0 to begin with. And then it's going to output mapping again. So we're taking mapping and we are modifying it and just writing it over the same attribute. So now you can see if I move in the x-axis here, then we get a horizontal movement of the noise, which is cool. So you can think about this as like the mapping node in shader nodes. And it's a little bit difficult because we don't have any, there's no visual cues about what's going on. It's just like the lines, it's just the geometry that you make. So whereas in shader nodes, you can actually see, okay, this is what the noise looks like. It's a little bit of blind faith in geometry nodes, but you do get used to it. It's just something that you pick up. So if I want to animate this, the horizontal sliding, then I need to use a frame to drive it. So let's add an input value node. And just like any driver, we can type in #frame. And now if I press play, you can see that this number increases exactly what the frame number is. So let's take a vector combine XYZ. Bass vocals, triangle, and melody. Triangle is like a very specific, a very specific one. Just for anybody on YouTube, that's what's being said there. Yeah, I mean, you would need to layer stuff up like that. You would either need to use animation nodes, or when you're baking your sounds to F curves, you can split, right, specific frequency ranges to be baked. I don't know how accurate it is, and I wouldn't even really know how to tell. Let me just show you. It's probably easier if I just take a quick screenshot. There we go. What is OSC, Pancakes? I know you've mentioned it twice now and I don't actually know what it is. Is that the MIDI node stuff? Because I know Animation Nodes is now able to like read MIDI files, which is amazing. Open source control. Ah, sick. Nice. Yeah, you could use OSC for it. I guess you would have to have your audio file split up already. But if you're producing the audio, like Perspeaks, I know for you could literally connect like microphones directly into Blender and have it live transform geometry like this. I know people like Matisse have done stuff with real sensors, like real life sensors controlling things in shaders, which is amazing. Or even cooler maybe is connecting some like physical sensors to your drumsticks. That would be maybe a cool thing to try. Okay, so to get this to move, I'm just plugging my frame, #frame, into the X of a combine XYZ, which is just in the vector group, and then plugging that into my vector of this attribute math node. So now when I play, this moves much too quickly. So I'm just going to divide this frame by 50. And there we go. So now we just have a kind of, it looks like it's moving sideways, but really each point is just moving up and down differently. So it's not generating new geometry, it's just moving up and down. Might even go a little bit higher here, so up to 80. There we go, something like that is cool. What I want to do is I'm going to position primitives on these curves. So if you've used Geometry Nodes at all before, you may well have done something like this. So you've added a plane or any object, right? And then some primitives. And you've taken your plane, created a new Geometry Nodes tree, added a point distribute node, which has generated a bunch of points. And if you set this to random, it just positions them anywhere. And if you set it to Poisson disk, then it lets you set a minimum distance, which is like a, you can think of this as having a weld modifier built in to essentially join or like remove doubles within a certain distance. And then you might have used like a point instance and picked your cube. And then you'll also probably want to do something with the scaling. So something like an attribute fill, scale. And there's a point scale node, isn't there? So you could have just done something like this. So this is fine if you have a surface to work with, and if you have, if you just want random distribution. But what we want is a regular, like grid layout distribution. We just want it to be spawning the points, the cubes in this case, on the vertices that we're generating. So if you don't use a point distribute node, then you can see that it's just putting them on the vertices of the object, or like the points of the object, right? And then if you were to use a mesh subdivision surface beforehand, then you can see how we can build up a grid very easily, like a regular grid. So what we're going to do is basically the same thing. So we're going to take our lines, and we have a subdivide on here. So if I was to, I wish I could preview where the vertices are, but I can't. So what we're going to do is we're just going to point instance objects on here. So let's generate a few objects. I'm going to generate a cube, and I'm just going to leave them as well right at the center. I'm also going to generate a icosphere, just one of these nice ones with triangles, and I'm going to reduce the subdivisions on it to 1. And in my outliner, I'm going to make a new collection called primitives, and I'm going to disable it. So now if I put anything into this primitives folder, you can see it disappears. So we've got our, I'm not even sure how many sides that has, but our icosphere with reduced subdivision. I'm also going to add a cone, drop that in my primitives, and I'm going to add a torus and drop that in the primitives as well. So we've got all 4 of them, and they're all in the same position, which is fine. And I'm just disabling that. So now what we can do is we can scatter, we can distribute them, we can instance them across the points of our curves. Now you'll notice as well that they're much bigger than we want them, so we're also going to have to scale our points. So to begin with, let's just add, I'm just going to do it this way. I'm going to add a point fill, sorry, an attribute fill. I prefer using attribute fill than a point scale, because the point scale has to use a vector to scale things, and sometimes you just want to scale it like evenly. So if you use a float and you set this to scale, so it's basically taking the scale attribute of all of the points, and because it's coming through this geometry here, it's reading every point that you're generating on your geometry. So it also respects scaling done in edit mode. It does. Yeah, so as long as your objects have been, you like Control A, apply rotation scale or apply scale, as long as the scale on your, on your transforms is frozen out as like 1, then it will match. So I'm just going to do it this way just because it keeps everything in the nodes, and I don't really like modeling stuff anymore. I'm quite used to just doing everything in nodes. So now let's take a point instance, and we're going to throw our collection. Let's expand this so we can read it all. I'm going to take my collection, and we're looking for the primitives collection. And at the moment it says whole collection, and our scale is much too small. So you can see if we take the whole collection, at every point it instances the entire collection. So this would be really useful if you've got something set up. Maybe you make something like a fence, and it's made up of a load of different objects, and then you can instance that whole collection, like a collection instance. So you could maybe like put a fence around a perimeter and have each one of the blocks of fence move up or down by a certain amount. Yeah, so that's kind of actually like maybe quite a useful way. I've been trying to work out what is like the production use of this software. Oh yeah, when they move they go crazy. It's just because there's a lot of stuff clipping as well. Yeah, so I've been trying to work out what like the production value, like use cases, intended use case for geometry nodes is. And at the moment, like all of the examples have been based around scattering and distributing things in a sort of organic way. Whereas what I'm used to is like using Sverchok and making stuff that's very, this piece goes here and this piece goes over there, and we extrude this very specific piece of it. So it's been like a little bit of a mental challenge, I guess, trying to work out how to use something which is quite difficult to pin down. I think stuff like that will become easier, and obviously you can use vertex groups to like control weights, size things, and move stuff around. Like you can transform a mesh by moving the points like we did with the noise before, but you could do that in a very intentional way as well. Anyway, so at the moment we're distributing the whole collection. Let's turn that off. And now what it's doing is randomly picking an object from the collection and putting it on each point. So you can see these all just move up and down, which is cool. Now I want to change the amount of this up and down distribution. At the moment it's quite strong, and I just want to bring it down a little bit. So this was our mid-level, and I think what I'm going to do is I'm going to change this from subtract, I'm going to change this to multiply. And now you can see we're getting just a bit of up and down movement now. So I'm going to change that to 0.6 just so it's a little bit smoother, a bit lower. And this is already kind of cool, but I want to get some random rotation on here. I want to get stuff like properly tumbling in quite a nice way. So everything that we do from this point forwards is going to be before the point instance node, because we are transforming the points. The instancing is just putting an object on that point. So if we were to do stuff to it beyond here, it wouldn't actually affect the point instance, because anything on this side of the point instance is kind of ignored by the point instance. So now we've got the instance on, I'm just going to drag that over there. Oh, I've got a random annotation. There we go, frame lock that. If you ever want to do annotations while you're animating, you need to frame lock the annotations, and it will let you actually do like multiple annotations. Okay, cool. So we haven't even got into doing the audio side yet, but I just wanted to make sure that this was all set up, kind of ready. I love doing stuff like this, it's quite simple. Yeah, like Pers is saying, like it's about like the generative aspect that's pulling you in, and it's like it's letting geometry nodes do its own thing and like take a little bit of the kind of creative control. It takes you into an interesting sort of moral discussion as well about authorship of artwork. Yeah, like rolling. Yeah, so yeah, with authorship of artwork, I'm seeing it quite a lot with crypto art. People are doing a lot of stuff with like GANs and AI stuff. And it's like, at what point are we where you are the one who's like directed the artwork, but you credit the AI as the one who actually produced it. I think that's quite interesting. Pancake, I think I've got something wrong after the hashtag frame. Oh yeah, hashtag frame by, I've got it by 80 at the moment, just so it's a bit slower. But it's literally just /80, just to slow it down. Okay, let's add some random rotation in here. So for each one of these points, I want to declare a random value, and then I want to add it to the rotation. So let's add an attribute randomise, and let's just drop this on here. So this is new. If you are if you had yesterday's version of the attribute randomise, then the today's one has this new drop down. I'm pretty sure it's today's, maybe the day before. So you can directly add, subtract, or multiply a value to these points. What we're going to be doing is we're going to be replacing creating. So we're going to set this attribute. This is going to be a new attribute to do with rotation. So I'm just going to call it rot. Make your life as easy as possible and use short attribute names. Because also when you accidentally mistype something, it's going to be a pain to like try and debug that. So we want to be generating a vector, and we're going to be generating a vector between, I want these to rotate in both directions. So between -1 and +1. So now each point has a randomly generated vector, just kind of sitting on it under the column. So if you think about your spreadsheet again, you've got a whole bunch of attributes so far. Like we've got scale, we've got position, we generated height, we generated mapping. So these are new columns for each one of these attributes that we make. And the spreadsheet is as long as the number of vertices that you have. So currently we are creating a new attribute called rot. It creates a random vector between -1 and 1, x, y, and z, for every single position. So now we can actually start using this. So if we were just to add this to the rotation value, so let's add a attribute vector math, because we're doing vectors here. So this is where we've run into issues with before. I was using an attribute math here, and I was doing, I was basically adding this to my rotation, and because I was using it with just the regular math node, it was just rotating everything in like this one axis. So everything was going at a different speed, but it was in the same axis, so it didn't look so great. So let's call our attribute with the attribute vector math. So we're going to take rot, and then we're going to multiply it, or actually we're going to scale it by the frame number. So basically at frame 1, we just have the rotation value. At frame 2, we have 2 rotations. No Suzanne's. Let me fix that for you. So let's add a new primitive into our primitives. Set a mesh. Monkey, here she is in all of her glory. Go away, and now, wow, there are a lot of her. So anything that you drop into your collections is going to get called to instance. So it's quite useful, kind of fun. You can throw in a load of variations if you're doing trees, if you're doing plants. Just chuck them all in a collection and instance them. There we go, praise be. I've been watching The Handmaid's Tale recently, and like whenever anybody says something, I just want to be like, praise be. Under his eye. If you haven't seen it, it's amazing, it's really good. It's also an 18+, so for any of the younger people in here, maybe avoid it. Anyway, I'm getting off topic. So what we need to do is we need to scale our rotation, or our random value that we've generated, our random vector. We're going to scale this. Our B socket is going to be a float, because we're using scale, right? Vector scale is like a multiplied by a scalar value. And then we're going to be outputting this to the rotation. So we're just overwriting the rotation at each point. So you can see if I increase this scale value, everything rotates randomly, in a random direction at a random speed. So now if I just take the, where are we? So I've got this value node which has frame divided by 80, and I'm just going to plug that straight into the scale value here. And let's make sure we can see all of our sockets. Put it here. Okay. So now when we play, these very slowly rotate. I'm going to increase that slightly. So I want a different multiplier in between both of these. So rather than this being divided by 80 here, I'm just going to have this as frame. That's going crazy. And then I'm just going to add some maths. So utilities math node. It'll just take you a few minutes to like remember where everything is on these lists as well, because obviously we used to like converter math nodes, and now it's under utilities. And it's also been split from vector math, which is under vector now rather than also being under converter. Anyway, you get used to it. So I'm going to divide my frame by 80. So now these move at a more sedate speed. Sorry, 80, not 50. And I want to make them spin a little bit faster. So I'm going to bring this down to 10. There we go. Just so it's a visible spinning. A super secret sway command. Yeah, the frame multiplied by pi by 100. It's only by 100 if you're doing by the length of the animation, right? You want it to be divided by the length of the animation, so you get a perfect loop. You could also, if you wanted to make it fully loopable, rather than adding just the frame here, so rather than having it just move in this direction, oh, it's doing that thing with my annotations again. We could have something like sine and cosine into my x and my y, and now everything's going to move essentially in a circle direction, and it's going to be constant. Oh, sorry, I've just been messing around with these. So we have got frame, hashtag frame. Going into a divide by 80. Let me just delete those annotations again. So divided by 80 for our x direction. And then we are dividing by 10 and plugging this into the attribute vector math, which is scaling our generated attribute rot, which is just a random vector per point. And we are scaling it. So I know sometimes it might think you can make a sheet cheat for these. Oh, you missed something with the rotation node, yeah. So we just, for each point we generate a random vector. Cheat sheet. Yeah, I thought so. And then we're scaling it. So I know it might think like, oh, when we're at like frame 200, surely it should be going like 200 times faster. But because we're essentially multiplying, for each frame that we go forwards, it just adds like one of the same amounts each time. So it's just a linear rotation. And then we write it over rotation. So anything that you write over rotation, position, or scale will directly affect the rotation, location, or scale of the points, because they're like defined vectors. They're like the important ones that you can't make do anything. They will always be location, rotation, and scale. Oh, you didn't have the frame plugged into the vector math node. Nice. Okay, cool. So we've got our rotation going. Now, I'm going to bring in a bit of music now. So we're actually getting into the music equalizing stuff. If you want yours to speed up, Della, you can just reduce the values that you're dividing by. Yeah, what did you want a cheat sheet for? Sorry, I completely blanked that. Was it for where the nodes are? Or for shortcuts? If you're wanting Node Wrangler, by the way, I'm sorry, there's no Node Wrangler. You can control right click to cut stuff, but there's no like alt right click. You can see that just disconnected it, which is not what you want to do. But yeah, so control right click and shift right click still generates reroutes, but we have no lazy connections just yet. Oh, for the for making stuff go in a circle, all you need to remember is that sine and cos together. So sine, because of the phase difference, it's like 90 degrees out of phase. So you've got sine, which goes like that. So you can think of like a point moving up. If this is time moving in this direction, then if a point moves up and then comes back down and then goes up again, then all you need to make this into a circle is to have it go in this direction and then back, right? But it needs to be out of phase because this needs to be all the way over here, like maximum displacement, when our sine curve is at 0, when it's in the middle. So luckily we have one of these because we have cosine, which looks, I might be completely wrong about this, but I think cosine is that one. So it's like 90 degrees out of phase. It just means that you can draw circles very easily with sine and cos. If ever you're doing anything with circles, just try like, and you don't know, like this is how I've learnt it, just try putting pi or 2 pi into values that might look like they would control something and change, like just start adding like sine and cos all over the place. It's amazing how many things end up just being circular. You really don't need to know much about maths, you just test it. Is there a reason that might? Yes, there is. If you have got a point instance node with whole collection ticked, then it's going to be pulling the entire collection as one object. If you uncheck this, then they should be in different places. Did that solve it? I hope it solved it, because otherwise I actually don't know. Unless you've got like 2 of these like this and then you're joining them afterwards with like a join geometry. Oh my god, I love it. This is our new multi-input socket, by the way. How many things do you reckon you can put in here? Sorry, just bear with me. This is research. Okay, so 3 is fine. Oh my god, I love it. And you can order them? Oof. Well, that's very satisfying. Does the order affect the output? I would about 1.5 million out inputs. Yeah. It is actually, oh my god, we've got like our little, very own noodle squids. I love it. Anyway, sorry, I'm so easily distracted. Right. So we don't need the joint geometry right now. Cool, so that solved the overlapping stuff. Oh, hold up. Oh, we were just very close. I thought one of my things was much bigger, but we were just close to it. Right, so we've got rotation, we've got movement. We're going to start using audio now. So if you've ever done anything with audio in shader nodes, then all you do is you grab an input value node in your shader, and then you keyframe your value. And then if you open up a, oh my god, am I being blind? Oh, graph editor. Oh, thank you. Then you can go like key with it selected. Oh my god, it's not actually coming up. So in previous versions of Blender, I don't know if this is just because it's an alpha, your selected node, right, would come up as a keyframe in your graph editor that you could then modify and make sounds to. However, we can't do this now. I mean, apparently not with either, but definitely not with geometry nodes. So what we need to do is we need to move an actual thing. So what we're going to do is we're going to add an empty, I'm just going to move it back over here. So obviously empties don't render, but just for cleanliness, I'm going to move it back here. And I'm going to call this one music empty. So now what I can do is I can keyframe the Z location. So let's just set, there we go, transforms. So just going to keyframe, just to insert a single keyframe at the Z, right? And now you can see in my graph editor, we've got this. I'm currently at frame 100. I want to be at frame 1 actually for this. So let's skip back to the beginning with shift left. And then on your menu, key, bake sounds to F curves. And then you can just select your music that you want to do. I'm using Distant Rendering by Harris Heller. Harris Heller is great if you want to make videos on YouTube or Twitch or whatever, because all of the music, the stream beats, if you look them up, they are free. They are CC0. So super useful. So now if I play this, you can see that we've got a little bit of movement on our empty, but we can't hear anything. So what we need to do is we also need to add so let me just split this space. We need to add a video sequencer. And then let's get back to the start here. Shift left, Shift A, add a sound, add the audio again. And now you can see that we've got this, this music track. Music track is also 716 frames long in my case. So I'm just going to update my scene here. 7/16. You can also sound a sound with a speaker object. Is this true? I've never actually used speakers in all of my years of using Blender. Oh my god, you actually can. Let me just mute this. Oh my god, it actually works. Crazy. Anyway, I'm just going to use the video sequencer just so it has 3D space. Oh, for like distance from the camera. Man, that is brave. If you're doing like camera, if you're doing animation stuff and you're doing all of your like compositing in the render and all of your audio in the render as well, then you also must be rendering out videos instead of image sequences. So, I mean, you do that if you want to, but that's, you can mix down 3D sounds. Oh, right. Okay. So just to repeat that process here, let me just zoom in as well so we can see this. If you, okay, wait, let me just do this first. So you've got your empty. All I did was I selected my Z location and I clicked insert single keyframe because I'm not interested in keyframing my X or my Y. I'm only I'm just doing the Z location. And then once you've got a keyframe, you can select your object, go back to the start frame with shift left arrow, just to bring you back to the beginning of the timeline. And then on your graph editor, go to key, and then bake sound to F curves. So as long as you have an F curve visible from being keyframed, then you can bake a sound to it. So you can see then that I've got this audio now on my timeline. Now, if you want to zoom in or zoom out, it can be a little bit difficult to like get it working right, because if you just scroll, it's gonna just zoom in and out regularly. But if you want it to like change the sort of the amplitude normalizing in here, I mean, you can actually just click normalize, I think, or maybe not. Basically just control middle click, and if you click up, then it scales it in the y-axis, and if you drag X, it scales it in the x-axis. And it's the same for the video sequence editor as well, if you want to get more of your clip visible. Import audio to F-curve modifier. Are there F-curve modifiers? Maybe not. It's just on the under the key menu anyway. Cool. So we've got our audio in, connected to our empty, and we've also got it in our video sequence editor now so that we can listen to it. So if I play, hopefully that's not super loud for you hearing this. So it's kind of chill music, so I'm probably just going to leave it going. No sound at all. Thrilling. Wait, Dre's can hear it. Maybe you'll have just got me muted. Just my voice. Okay. Maybe the, yeah, my voice volume is probably fine, but the stream volume. I mean, don't worry if you can't actually hear it, because you can just see the empty moving. Okay, so we now need to get this information into geometry nodes. So whereas ideally we would have just used a value node, and this would have allowed us to just bring in a value directly, we're just using it 1 of 100. Oh, it's probably because I think I've streamed games before and it would have been loud. Or maybe when I was streaming last week or something. Anyway. So let's pull the empty into our geometry nodes graph. So Shift A, input object info. And we just want to grab the music empty that we've just generated. So we can pull a number of attributes, so location, rotation, scale, and the geometry. So we don't actually have any geometry here. And all we're interested in is the Z location. So let's also use a vector separate X, Y, Z. And we're just going to pull Z from here. So we could do a number of things with this Z value. You could multiply by, where is it? This one, right? So you could change the scaling on your, like your Z axis here for your scaling the height that we did originally. Or you could change the size of your objects. In fact, let's just test a few of these things, see what it looks like. Is there a way to read those values? Currently, no. There will be a spreadsheet, but currently, no, there is nothing. If you do more complex things, it can be a little bit difficult because you're like, okay, so this node is carrying a 2, and then this one, it's got changed to like a 1.8, and then at this one, it's like, you know, you're trying to do like maths, like logarithm in your head. So it will be super useful once we got the spreadsheet viewer, which is just going to be like a viewer that just lets you view all of the attributes simultaneously. Apologies to any devs if that's misinformation, but as far as I'm aware, that is what's going to happen. So what I'm just going to do here is I'm going to adjust the scale without Z value. So that's kind of funky. So you can see how this could already be used, to be honest. If you're doing, you know, like when people download Mixamo, dance, loop animations, and then they like put particles all over them. You just do that with geometry nodes and it would probably be actually quite performant. And then you could put your music directly in here. The Z into the subdivs. Do you know, I don't know if, because this is an integer, and I kind of, oh man, am I going to do this? Now you've mentioned it, I can't not. I just want to see. Okay, so let's take a map range Z. Let's do a stepped linear. So we're going from 0 to, do you know, I don't actually know how high this is going. Like 0.2 at most. 0.3, okay. That's 0.4. We're going to go up to 4, just so it's nothing crazy. Is it going to read it? No, I'm afraid not. No, we need a float to integer node so that we can convert. Okay, but we can plug it into the scale and then do some like function of this. And I guess we probably don't want to have this go above like 0.1. So that's kind of cool. The floor ceiling node is still going to push it out through a grey socket, I believe. Yeah, I mean it's on the math node, so you're still working with scalar values, not integers, which require this green socket. Let me turn this base up a little bit, or the base value up, just so it doesn't ever go down to completely 0. Yeah, I mean it's just exactly what like Eric was saying earlier. You just kind of get messed in there, or lost in there, just playing with values and just seeing what kind of comes out of it when you stick a random value on something. Go a little bit smaller than that. Okay, cool. Now I also want this to affect some Z height. Man. Anyway, so what we're going to do is we're going to add a random value per vector to the Z. Wait, so the music empty could also drive shaders? Yeah, for sure. Could it? Wait, could it? Hold up. I mean, I think so, right? So copy as new driver, go into our object here. Let's just stick this material on everything. Link materials, there we go. So everything's currently blue. Let's go into this factor here and paste driver. Yeah, you totally can. So I mean, you actually have to do it as a driver. And then I'm also probably going to want to remap it in here. So let's stick this on a math node and multiply it up. There we go. Damn, you're a geniuses. This is why doing streams is fun, because it's like a group project then. Emission strength by the driver. Yes, okay. Wait, at some point we're going to have to push forwards with the geometry nodes as well. But I feel like there's a whole shader setup that we can do as well. That's just going to randomize shader. Maybe we should do the color by the amplitude, or do like a hue transform. Okay, I'm sorry, just bear with me here. So we've got our principal shader. We've got a random value, because we're instancing objects here, right? So we can just use an object info node, random, and you can see we've got a random value now. And then we can push this through the bloom intensity and EV. You know, you actually could do it on the bloom intensity as well. Just because it's drivers, right? And everything in Blender interface is Python, so you can drive at anything. Okay, convert to map range. Set this from linear to constant. Add a few flags. If you ever do this as well and you want to make a color palette, color ramp, add some flags. This drop down, you can distribute stops from left. And now you have even distribution. And then you can just start throwing some colors in. Let's put some blue in here. And there we go, something like that. And then let's mess around with the Blender's just so much fun. I swear more people should get into this. Let's just throw this into the hue. That's pretty cool. And then we could also change this into the emission strength. So beautiful. I think maybe it goes too high for the emission. Okay, nice and colourful. Right, back to geometry nodes for a little bit. We're going to take a random value, right? And just we're going to... No, I was going to say we're going to linear light it, but I think we're just going to add it. Linear light's fun, but it is more computationally heavy than just using an add. So let's create a random vector. So attribute randomise. We need to create this random vector, which we're going to call music. So float vector attribute is going to be called music. And it's just going to be a random vector between minus. So we only want it in the Z as well. We only want this one in the Z. So -1, so 0, 0, -1 to 0, 0, 1. So now we're just moving up and down. And then we need to add this to the position. Or, yeah, we need to add this to the position vector. So let's take an attribute mix. Sorry, I'm just thinking on my feet a little bit here as well. So attribute mix, we're going to add float for the factor. We want to take the current position and we want to add music to it, right? music, and the final output here is going to be the position. So we're overwriting the current position, as you can see there. So randomized, not randomized. It's on there. And let's take the Z into our factor here. So now you can see that stuff is getting like thrown off by the sound, which is kind of cool. Now what if we want the front row to be not affected and the back row to be affected? So if this was a shader, you would want to have a gradient from the front to the back. However, we can't just generate one, can we? I was going to say that we would have to use we'd have to like create a blend gradient in the shader, or sorry, the texture properties. I'm now wondering if we can just call generated, because if we could call generated as an attribute, then we could just use the Y component of it. So that would be super useful if we could do that. Let's give it a go. So this has to come before we affect the position. I'll just stick it in here. Sorry if this music's getting really repetitive. You can just mute the stream if it's annoying. Oh, I might just wait. There we go. So once it's big like this, then I'm going to, just for a moment, I'm going to disconnect it from the scale. 0.01. There we go. So everything's really like scattered at the moment. So if your music is affecting all of the axes, then it might be that your attribute randomise has values in the, well, I mean, it would have defaulted to 111 as your max factor. But you just want it to be 001, just because you don't want to be affecting X or Y. I would assume that is probably what might be causing it. I mean, even if you did bake it to all axes on the empty, because we're just pulling the Z. Oh, are you using an attribute mix or an attribute math node for your joining it together? Because this might be one of those things where it's like you've joined it together on a math node, which is like broken your vectors down into scalars, which is kind of annoying. It's just difficult to keep track of when you don't have socket colors, when everything's hidden behind an attribute. But you do get used to the workflow. So I'm going to try and call the attribute the generated attribute, which would be like, hopefully, generated. I mean, if you want, you can drop your file in voice chat text and somebody might be able to have a quick look. Or I can have a quick look. So let me just call separate XYZ, attribute separate XYZ. So we're calling our vector, which is potentially generated if this actually exists, generated. And we're writing the y-axis, again, if this exists, to gradient, just to see if this works. Just before we do this, let me grab Pancake's file and have a quick look. Hopefully the stream is still running for you. It's just probably paused it for a sec while I've opened. Oh, is it still running? Sweet. So you've got your Z going into the factor position music position. You are mixing, your attribute mix is set to mix instead of add. Is that what I've got mine set to? Yeah, that's it. Cool. It's so easy to do that though, so don't worry. Okay, so let's see if this pulling a gradient worked here. I don't even know if generated is actually an attribute that we can pull. What's the factor to the attribute mix? This is my, sorry, let me just actually bring this over here. It is the Z position of my music empty. So basically just the music amplitude, because we baked the sound to the Z. I did get rid of the map range. We were only using the map range on the scale anyway. Oh, Nutaki, no worries, man. I will remind me to send him the box cutter link. I will do that later. Cool. So we would like to, if this is the front, then this should, in theory, have a value of 0, and the back should have a value of 1, which would mean, hypothetically, that we could just multiply the music by the gradient. So it's the change in amplitude. Basically, this factor needs to be multiplied. Yeah. So at the moment we should have a scalar value because we're just pulling the y. This is kind of why I prefer shader nodes or even like Sverchok. I'm really enjoying using geometry nodes, don't get me wrong, but using attributes is like just constantly having to focus on, oh, is this scalar or is this vector? And it's just like, I don't know. It's like an extra bit of thing that seems unnecessary. Like I don't really understand why it needs to happen, because you can create amazingly intricate things with Sverchok and animation nodes without using attributes. But I'm sure it's useful. I'm sure it is. It might just be a better way to develop something. So in this case, we're going to be using attribute math because we're using scalar values. We're going to be taking gradient. We're going to be, our B is going to be a float value. This is going to come from our music. Let me just make a little bit more space for you to see. It seems Houdini. Yeah. Houdini is super powerful though, so I guess maybe they're onto something. And we're outputting, I'm just going to call this one the amplitude, or amp. And then instead of using the factor for the music here, I'm going to use an attribute here. And we're going to call this factor amp. So I would say that did nothing. So it looks like you can't just call generated as the, yeah, I don't think that's got any difference front and back. Yeah, no, for sure. So you can't just call it from here. We're going to have to generate a gradient in the texture properties panel. So let's go over here, create a new texture. It's a blend, is a gradient. And which way does it need to go? Horizontal is going to be X, vertical is going to be Y. But as a Houdini user, do you think it works the same? Oh, right, yeah. Hey there, because you do quite a lot of Houdini stuff. I mean, I definitely see when I watch videos for Houdini, a lot of like attribute use and sending stuff between node trees. And I think when we can share attributes between node trees and start writing things a bit more like absolutely within Blender, then I think it's going to be a lot more powerful. Just at the moment, it feels like we're just using attributes within one node tree. And if we're just using it there, then we might as well use visual connections. But hey ho. Okay, so rather than using the attribute separate XYZ, which did not work for us, we're going to be using attribute sample texture. We're going to be calling our new texture, which is going to be called gradient. So there we go, gradient. And our mapping will be, we have no faces, so we have no UV map. So I'm going to call this position. And we're going to be writing the output as gradient, which is just the attribute that we used before. Cool. So now another thing to consider. We have got position for mapping our gradient, and our gradient is going to go from 0 to 1 in Y, right? So our gradient is going to go from here to here because we're using the position vector. So either we can move our object in edit mode, so we could literally just grab it and move it up like this, or we need to do something to our position. Now, I'm all about ease, so let's just move our geometry, and there we go. So now, in theory, we should have a gradient, which is affecting how much of our amplitude is going on. So yeah, the front line here isn't getting distorted at all by the amplitude changes, whereas the back line is being affected quite a lot more. Taylor says, struggling with the attributes. Yeah. I mean, there's nothing really that can help you with attributes. That's like the really difficult thing. Until there's like a fuzzy searching thing, or you know, like when you're using the script editor, you can start typing something and then press tab and it will come up with all of the options. We don't have that yet. I'm hoping that there will be that, because at the moment this is not beginner friendly. Like I want to be making beginner tutorials for this stuff because I want to share it and I want people to enjoy using it, but at the same time it's like it's very difficult to frame attributes as beginner friendly. Yeah. I think people don't really get the idea that you just type something and then suddenly it's an attribute. That's kind of a weird idea. Yeah, you lost the pump effect. Oh, from the... oh, they're working on visualizing attributes. Oh, no way. That's so good. Runners, do you have any like developer links or anything that you can like, that would be good reading for that? Also, thank you for the combine separate XYZ. They're super useful. Yeah, so the pump effect, Stella, that was from the scale. So I will just bring that back. So that was with the An inline script node would be cool. Yeah, like in animation nodes and Sverchok, you can just like write a script directly, or like mathematical expressions. I saw a proposal Runners did for just like you type in the maths expression and it automatically generates all of the attribute vector nodes and math nodes, which is really cool. Okay, utilities map range. Let's take our Z value and bring it back into our scale. So from 0 to 0.5, they're arrays of values. I don't really see that as a problem. Like, I know I keep coming back to Sverchok, but that's just because it's what I know, and I know Grasshopper as well. And in both of those, you would just have a list of values. You know, you would just like pull something like vertex positions or an attribute, and it would just give you a list, like a nested list as well. But I mean, a spreadsheet would just be fine. I don't think there's anything wrong with Blender using a spreadsheet. In terms of like interface integration, I think it should work fine. Okay, so we've got the scale pumping back a little bit, and it's just down to finessing your values to something that you want. See you later, June. So for size, I'm going to go for 0.01 up to 0.17. So there we go. And I would like the difference for these back ones, like the random value that we're adding to the backhand, the backlines. I want that to be way, way more. So what I'm going to do is I'm going to add an attribute color ramp. We're going to take our gradient attribute, which is our gradient, literally our gradient. And then we're going to overwrite the gradient. So the attribute and the result is going to be gradient. And this is going to let us move where these handles affect, basically. So we have scale happening way back here. And I think it might be cool to have the same kind of effect as we're getting with this this gradient, like not affecting the front ones so severely. So I'm going to move this forwards as well. So I'm just going to select it. I'm going to press Alt to pull it off. Everything's got really big because it's gone back to a default size of 1. So let's pull that forwards. So I'm putting the scale just as the last thing here. Whoa. The issue with making shaders like this that are musical is it starts to like wear you down, like listening to it on repeat. Okay. Oh, it's not even a shader, a node tree like this. Adding an offset with each beat. How do you mean? Oh, you just mute the sound. I mean, I could do that actually. Oh yeah, oh, that's kind of a lot better. I feel almost like whispering now, like I'm in a library. Okay, so it's affecting the sound, and let's just increase the amplitude that this shifts. So this attribute math in here, I'm going to increase the output on here. So I'm going to use a map range, and I'm going to increase this to like 2, just so it's like going kind of crazy at the back. So you can see things get way bigger. And I'm also going to just reduce this down to 0.1, the maximum size. So you can see when there is a loud beat, everything kind of gets thrown off quite a lot. But our front row, and we'll do something in the shader, so our front row is like a constant color so you can see it. But there we go. So that's no longer affecting the front row because we can now control our gradient with the color ramp. This is all coming together quite nicely. So let me just rearrange a few things, bring them back, and then I will drop a screenshot into the chat just so you can see where we're at now. I will drop 2 screenshots into the chat. So here we are up to the gradient. And then let's get the rest of this. Okay, so that is the current position of the node tree in case you do need to check against it. I'm just going to do the same thing that we did for the amplitude changes here to the attribute, to the scale attribute. So we're not having such an intense change of the scale at the front row. So basically what we need to do is multiply again the attribute that we're putting in here. Can I do it with the amplitude? No, I just need to do an attribute math here. So take another attribute here. I'm going to be calling this one amp underscore scale, just because we're doing a different one. And again, we're taking the gradient, so the same gradient that's affecting the amplitude. And the attribute fill, instead of a float, I want to do it with a vector. So that needs to be an attribute math node. So we're using attribute fill before, which essentially just does like a paint bucket fill of a particular value, vector, color, or boolean across the entire attribute. Because we're now doing it with attributes, what we can do is we can take an attribute math node. Our output is going to be scale. Our input is going to be an amplitude scale multiplied by a float. So now you can see we can actually have like a control here with the size. Now that front row is tiny now. But it's just because it's being multiplied. I see, multiplied by 0. So that's actually, that's too much. Okay. So what we could always do is we could take our gradient and just alter it differently over here. So we're taking gradient, we're going to be outputting grad underscore scale. So just keep in touch with what attribute names you're using. So I'm making sure that my nodes that use those attributes are next to each other, just so that I can see them. Obviously, a noodle connection would be more convenient, but there we go. So just messing around with these values until it kind of comes out looking cool. So we can see the back is bigger to begin with, and it has like more of a punch effect when it gets even bigger. And there we go. So let's do a little bit of shader stuff. Yeah, let's do a little bit of shader stuff, and then we'll have basically like covered. I mean, we've used a lot of nodes already here. So we've covered quite a lot of stuff to do with like attributes and controlling meshes. The only thing that Geometry Nodes currently really does that's sort of outside what we've covered is like random distribution. So if you're using it for scattering grass, scattering foliage, scattering rocks, things like that. But we can do other videos. There's quite a lot of content already on YouTube as well about that. So let's just work on our shader a little bit. I want to have a different impact for the ones at the front than at the back. I'm just changing my gradient to have less of an effect there. There we go. So I want my front row to always be visible. They are actual developers in the blender.chat. Yeah, for sure. Like you see some of these names coming up in the commit releases things. So that's actually another really good another good resource that I will drop into the YouTube description. I'm losing my words. Okay. So last little bit here, let's grab an input texture coordinate node, and we're going to use generated. There we go. Oh wait, no, we're not going to use generated because this is not the material which is on like the whole thing. It's not one object. It's using instances. Right? So every object on here is unique. So what we want to do is we want to set the world position. So what we're going to do is we're going to come in here, grab geometry node instead. Then we can use the position vector. Let's take a converter, separate to XYZ. We're going to take the Y vector here. So we've got 0 and it comes up to like 0.7-ish. But again, we can control that with a map range. And what I would like to do is have I feel like a base color, and then everything, like when it does those loud beats, everything jumps to the fun colors. So maybe we can have, yeah. So what I'm going to do is I'm just going to join this up. We're going to use a mix RGB node to mix between a flat valley, which in this case is going to be like blue, maybe? Something like this, and then it's going to flip over to the funky colors, and it's going to flip with the amplitude. So I'm just going to use a map range on here just so I can control the values a bit easier. And I'm going to plug this into the mix factor. So from 0.5, there we go. So it should become there we go. When the music's louder, you get more colors. And I never want there to be fun colors right at the front. So I'm also going to use a gradient just to multiply this this factor. So this is the Y gradient, which is black at the front. So anything multiplied by 0 is 0. I'm going to use another map range on here. So you can see I've just made sure that the front row is absolutely 0. Like that. And then it fades out. And then I can just use a math node, set this to multiply on here. So now the back ones get all of the color. I can just bring this down a little bit. Something like that. And I want to set my world shader to be black. Bradley the YouTuber, yeah. Bradley makes really great animation nodes tutorials. Like really top drawer stuff. I feel like I learnt most of my animation nodes from Bradley. So to render this, you've got to be in cycles, unfortunately, because we're pulling an attribute into the shader. So I've just made my world black. So it's a little bit slow just because it's loading in cycles. Oh wait, do you know what? We're not using an attribute. We're just using a driver. So we can do it in Eevee, which is good because now we can use Bloom and you can render it quicker. So turn off transparent film. And we're going to set the world color to black. And actually I want to see that. There we go. Let's set a base emission strength of 0.x and go up to 0.8. And go up to 2. So you can start having loads of fun with this. What was I doing here? Oh, this multiply, sorry. So I'm going to replace that multiply with a map range, just so that I have more control over the max min values. Yeah, multiple audio layers with, yeah, it's going to be so good having the kind of interoperability between geometry nodes and Sverchok animation nodes. I've done it with, I'll show you something in a sec actually, just because it's quite convenient. So 1 and then 8 and then 0.5, there we go. So what we have in here is we have all of our lines. Obviously you can finesse this to be like a little bit more readable. I feel like it goes a little bit too crazy at the moment. So you could always reduce like your max min values on here to like minus 0.5 to 0.5. So you can get layers of stuff going on if you are kind of smart about how you work procedurally between shaders and geometry nodes. But even just with geometry nodes in this super early state, we can get quite a lot of cool things. And obviously this is still live geometry, you know, so you can, if I come in here and grab some vertices, you know, if I move these, then you can see that we're actually still able to move like move an edge around, you know, and like bend one of these things, which is kind of cool. You could do all sorts with this. So if I was to actually just like remove that and then just like knife line through, oh, I can't do a knife line. No knife without faces. So there we go. I've made a center cut and I'm just scaling up the ends. And because it's subdividing inside geometry nodes, we're having this bend around in a kind of cool way. There we go. So you can do all sorts of things already. Sweet. So let me just show you one more thing here. If you use Sverchok, then you can use curves, and I'm sure you could probably do this with animation nodes as well, but especially with Sverchok, just because I know. So curve, something like a Bezier. At the moment, you cannot use nodes, geometry nodes, on curve objects because they're not geometry, they don't have meshes. So what we need to do is we need to turn this into geometry that we can instance across. So if we open up Sverchok, I'm just going to do this super simply. So create a new node tree, add a scene object in, and I'm just going to get this selection. So now we're pulling this Bezier curve into Sverchok. and I can do just a visualize mesh viewer so that we're taking the mesh directly out. And we just need vertices and edges. Right, so just these two nodes, that's all you need. And we will need to turn on live updates, unless you just play the animation. Yeah, probably easier just to play the animation. So I'll leave live updates off. So now what we've got is we are generating this mesh alpha, which you can see here. So it's outputting alpha. We need to apply the matrix actually because we just moved it. So let's also add a transform matrix apply, and let's just make that there. So what this does is it applies the transform basically when we moved it over. Now we have alpha in the correct position, and it's a mesh object now. So now with alpha selected, we can generate a new geometry nodes tree and do something like instancing an object like, let's put Suzanne on it, and let's do a point scale vector. Let's just reduce these down so that we have separate Suzannes. There we go. Just jump to our Bezier. So if you need to have curve control, at the moment it looks like nothing's happened, just because we're not actually calculating anything, because we're not either doing a live update over here or playing the timeline. So let me just mute the music. So now you can see I've got a spline with Suzanne's instanced by geometry nodes. So if you want to do mixed stuff, as long as Sverchok or animation nodes is happening before geometry nodes, you can do anything. So it's just, that's the important thing. It just has to happen beforehand, because as far as I know, neither Sverchok nor animation nodes will calculate geometry nodes modifiers. I don't know if that's going to be supported, I hope it is, but currently we just have the option to use it beforehand, which does mean that you can do fully procedurally generated meshes and then control them or instance over them with geometry nodes. Okay, that's it. That is my lot. That is my sales pitch for today. I hope this has been followable and moderately interesting. And there we go. If anybody has any questions, shoot them over, and I'm sure somebody will answer. And also, if you make anything with geometry nodes, drop it in the showcase. Yeah, that'd be cool. It's always fun to see what people come up with. And also push what you can do, like push what geometry nodes is being used for, because it's such a new thing. And I feel like so many times I just see on Twitter people doing like scattering and stuff like that, and I don't know, it'd be quite interesting to see somebody sort of breaking Blender to make it do something else, which is always fun. Also, we're going to be doing more streams again. So this is the first one of 2021, but we're going to be doing more shader streams and more geometry nodes and more Sverchok, definitely from me. And I'm sure Charon is probably going to do some shader stuff. And I know JC was mentioning doing something about vector displacement. So a lot of things hopefully going to be coming down the pipeline to you soon.